Okay. A given volume of gas has a temperature of 100 K. Oh, now we're working with temperatures. So immediately I'm going to start writing things down. So they gave me a temperature. So I'm going to say the initial temperature T1 is equal to 100 K. That's a capital K, sort of. And initial pressure of 225 kilopascal. So that's P2, or P1, I'm sorry. And that's 225 kilopascal. That's a lowercase k, sort of. You guys have no idea how difficult it is to write on this thing. And then the same volume of gas has a pressure of, so here's the second pressure, 450 kilopascal. And then it says at what temperature does this gas have a higher pressure? So they want to know what T2 is, the final temperature. So now I have two pressures and a temperature, and I need to figure out the relationship of the two. So in your worksheet, I know what I'm supposed to do, but you tell me what you think I should do. I want you to look at that and tell me which formula I should use. Is there a formula that you guys think I should use? It's right on the front. There's Charles' law, there's Boyle's law, and then there's the combined gas law. You combine gas law, right? So let's do that. So the combined gas law is P1 V1 over T1 is equal to P2 V2. But it says the pressure's the same. So if the pressure's the same, isn't V1 the same as V2? Not pressure, volume. I'm sorry, I said the wrong word. But isn't it said the volume was the same, right? So V1 is the same as V2. So normally the formula I put what here? V2. But is it okay if I just say V1? Yeah, because it's the same volume. Now you might say, Mr. Adams, why did you do it that way? Well, if I divide both sides by V1, what happens to the V1s? They will cancel. So I'm left with, even though we use the combined law, I'm left with like kind of a new formula. And that's this P1 over T1 is equal to P2 over T2. Notice that I have 4 variables. I know 3, and I'm solving for the 4th. Well, I want to know what P2 is. So I could play, let's try it this way, because I know some of you guys will try it this way, and I bet some of you guys are curious. So if I put P1, right, so if I say P1 over T1 is equal to P2 over T2, then my initial pressure of 200, I know some of you guys will do it this way, so I'm going to try and show you how. It doesn't matter as long as you do the algebra right. So my P1 over my T1, which is 100 K, 100 Kelvin, is equal to P2, which is 450 kilopascals, all over T2, right? Now that's a proportion. Does anybody remember how to solve proportions? What do you do to solve a proportion? Has anyone ever taught you the bat and ball method? No? Well, to solve a proportion, you're going to do cross multiplication. So I'm going to, and then solve. So I'm going to take this and multiply this together. So I'm going to say 100 100K times 450 kilopascal is equal to this stuff. That's how you solve a proportion. And we're going to say T sub 2 times 225 kilopascal. Okay? You guys with me on that? I'm going to have to go to another slide because we're running out of space on this one. So let's do that. So if I rewrite that whole thing on this slide, if I say 100 Kelvin times, what was it? 450 kilopascal? And that's equal to T sub 2 times what? 225 kilopascal. What do I do to get T sub 2 by itself? If these two items are being multiplied, whoops. What's the opposite of multiplication? Divide. Yep. I'm going to divide both sides by 225 kilopascal. Whatever I do on one side, I got to do on the other. What happens with my kilopascal? This unit here should cancel with this unit. So then I just got to do the math. So I'm going to say 100 times 450 divided by 225. Whoops. And I got 200. 200 what? Well, it's 200. The only unit that's left is Kelvin. That was a horrible Kelvin. And that is the temperature. Okay? All right, so the remaining two, you guys can do on your own. So I did the first three, you could do the remaining two. The bell's going to ring shortly, so I guess that's your homework. Okay? Any questions?